Hey guys, Miss Raymond here today for math to talk about finding experimental probability. All right, so we have previously found the likelihood of an event and the probability of an event. So today we're going to look at lesson 9.2 from Big Ideas Math, and we're going to start with the key idea. All right, so experimental probability, the probability that is based on repeated trials of an experiment is called experimental probability. So you are finding the probability of the event, which is equal to the number of times the event occurs over the total number of trials. Okay, so it could be spinning a spinner, flipping a coin, rolling a dice, drawing numbers or letters or marbles or something out of a bag. So we will look at an example of that. All right, so here is example 1, finding experimental probability. This is example 1 from Big Ideas Math. All right, so we have the bar graph here that shows the results of rolling a number cube 50 times. So number cube is the same thing as rolling a die. What is the experimental probability of rolling an odd number? All right, so we're finding the probability of rolling an odd number. So we need to go over here to our bar graph because this tells us the number rolled. So 1, 2, 3, 4, 5, and 6. So we're just looking for our odd numbers. So that should be 1, 3, and 5. And so we need to know how many times that number was rolled. So number 1 was rolled 10 times, right? So 1, so there were 10 ones. Number 3 was rolled 8 times. There were 8 threes. And number 5 was rolled 11 times. Okay? So the odd number of 10 plus 8 plus 11 gives us a total of 29 times that an odd number was rolled, and a total of 50 rolls, because 50 rolls or 50 times was the number of times this experiment was conducted, right? All right, so you're finding the probability of your event. In this case, it's the probability of rolling an odd number. And you're putting the number of times you rolled the odd number, right? That's the number of times the event occurs. So that goes on top. So that is 29 over the total number of rolls, which was 50. Okay, so your experimental probability is 29 out of 50. Or if you change that to a decimal, 0.58 or 58%. Okay. All right, let me clear those drawings. All right. And all right, so we are going to look at our new problem number 1 from Big Ideas Math. So this problem says in example 1, what is the experimental probability of rolling an even number? So we're going to go back a slide and look at, remember this was example 1, right? So we found out the experimental probability of rolling an odd number. Now we are looking at rolling an even number. So we're using the same data, right? But we're looking at even instead of odd. So let's look at our even numbers. So we have 2, 4, and 6. Okay? So for 2, that was rolled 4 times, right? And 4 was rolled 11 times, and 6 was rolled 6 times. So those are our 3 even numbers. right? Let me make sure I wrote that down. Oh, whoops, that was 2 was rolled 4 times. All right, so we've got 4, 11, and 6. Okay, so let's go ahead and go to the next slide. All right, so we had 4, 11, and 6, right? So probability of rolling an even number, which we got from our bar graph. All right, so we're going to add these up. So 4 plus 11 gives me 15, and 15 plus 6 gives me 21. All right, so 21. All right, so we were finding the experimental probability of rolling an even number, so 21 is going to go on top, right? And then on bottom, that should be the total number of rolls. So we go back to our previous slide. It was 50, right? So 50 goes on bottom because that was the total number of times the dice was rolled, right? So that should be 21 over 50. So our probability of rolling an even number is 21 over 50. If we wanted to change that to a decimal, that would be 0.42 or 42%. All right. All right, so if you don't have paper and pencil and a calculator, now would be a good time to get those and pause the video. All right, so hopefully you have your paper and pencil and a calculator if you need it. All right, so we are going to practice with 2 problems, the mini assessments. I really want you to give it a try. I will, go over it and we'll work through it, but I want you to give it a try. All right, so you have 3 sticks. Each stick has 1 red side and 1 blue side. You throw the sticks 10 times and record the results. Use the table to find the experimental probability of the event. All right, so this was the results of our experiment, right? So here's our outcomes: 3 red sticks, 3 blue, 2 blue, 1 red, and 2 red and 1 blue. And then here's our frequency column, right? So 3 red was 3, 3 blue was 2, 2 blue, 1 red was 4, and 2 red and 1 blue was 1. All right, so now that we know that, we are looking at problem 1, which is finding the experimental probability of the event, which is tossing 3 blue. Okay, so, all right, so we know we are finding probability, right, of 3 blue. So this is the experimental probability that we are finding. So we need to go over here to our chart and look, and what was the frequency of 3 blue? Well, it was 2. So I'm going to put that number on top, right? And on bottom should be what? The bottom should be the total number of times the stick was thrown, which was 10 times, right? That's going to go on the bottom. Oops. You might think we're done, but if we can simplify, we should simplify. And 2 over 10, I know I can simplify, right? I'm going to divide by 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. So probability of tossing 3 blue sticks is 1 over 5, or 1 out of 5. All right? All right. So there we go. That was the correct answer. I was just double checking to make sure we got it right. And so let's try a second problem. We're using the same the same chart, the same experiment. So this is the same table. This time we are finding the probability, experimental probability of the event of tossing 2 blue and 1 red. Okay, so the first thing we need to do, so probability of our event, which in this case is what? Our probability of 2 blue and 1 red. All right, so what is that equal to? Well, let's go over to our chart. How many do we have for 2 blue, 1 red? The frequency was 4, right? So that's going to go on top. The number of times that event occurred in our experiment. And then on the bottom should be what? Should be the total number. So what was the total number? The stick was thrown 10 times. So 10 is going on the bottom again. So 4 over 10, but is that in simplest form? I don't believe so. So I know 2 even numbers, I should be able to divide by 2. So I'm going to divide by 2. So 4 divided by 2 gives me 2. And 10 divided by 2 gives me 5. Okay, so the probability, experimental probability of tossing 2 blue and 1 red is 2 out of 5. All right, so hopefully you learned something about probability and experimental probability, and I've assigned for you to practice on IXL.com and then also do a practice written lesson. All right, so stay safe and I'll talk to you later.